Okay, now let's look at example 11. 2-point charges Q1 negative 3 microcoulomb, Q2 negative 5 microcoulomb are placed 12 cm and 30 cm from the point P respectively as shown in figure 4. So we are given here Q1 negative charge, Q2 negative charge, and there's point P here. Also the distance between the point P and the charges. Now determine the magnitude and direction of the electric field intensity at P, the net electric force exerted on Q0 equal to 1 microcoulomb if it is placed at point P here, and the distance of a point from Q1 where the electric field intensity is 0. So this example is actually kind of similar to example 4 in 1.1. So before this example 4, we find the value in terms of electric force. Now we find in terms of electric field. Okay. So macam biasa, first thing you need to do, you need to determine the direction first. Okay, so since we want to find the magnitude and direction at point P, so we need to find what is the direction daripada Q1 ke point P, and then point P relative to Q2. Okay, so since this one adalah negative, the direction will be going towards the negative charge, and then you label E1P, and then sama juga this one, dia adalah negative, so it will be going towards the negative charge E2P. Okay, so next one we need to do is we find the magnitude value of E1P and E2P. Okay, and then masukkan the value. This one E1P, so Q1, 3 exponent negative 6 divided by the distance from point P to Q1, 12 centimeter, convert to meter. You will get 1.875 exponent 6 Newton per Coulomb. And since direction dia adalah going to the left, so here, okay, you write down to the left and then it will be negative. So for E2P, sama juga, you just masukkan value Q2, 5 exponent negative 6 divided by the distance 30 centimeter, and then tekan calculator, you will get it is equal to 5 exponent 5 Newton per Coulomb, and the direction is going to the right. So going to the right will be positive, and then you just write down to the right here. Okay, this one mesti tulis. And then after that, tambahkan macam biasa to find the sum of the resultant of the electric field. So E1P plus E2P. And since E1P is to the left, so it is negative. And then tambah 5 exponent 5. It will be equal to negative 1.38 exponent 6 Newton per Coulomb. So since kita dapat negative, the direction will be to the left. Okay, so that one for question A. Now question B. Okay, determine the net electric force exerted on Q0 that is equal to 1 microcoulomb if it is placed at P. Okay, so now we imagine we place a positive charge here. So kita imagine kita letakkan positive charge dekat sini, which is equal to 1 microcoulomb. Now we want to find what is the net electric force. So we want to find the value for F now. Value for F. So this one, we can either use the method in first subtopic. Maksudnya kita carilah juga direction, what is the direction of the electric force, and then we find the electric force for each of the direction lah. Okay, but that one will be a long calculation lah. So since kita sudah dapat the electric field strength here, we can use the formula for electric field strength, which is equal to F divided by Q naught. So just masukkan the electric field strength is 1.38 exponent 6 equal to F, the force, divided by the Q naught. This one is given here, 1 microcoulomb. So kamu akan dapat force will be equal to 1.38 Newton. Okay, and last one. Okay, we need to find what is the distance of a point from Q1 where the electric field intensity is 0. Okay, so let's draw this one again here. So what we have is we have negative charge, and then at the end of this is also negative charge. This one Q1, this one Q2, and then the distance from here to here is 12 plus 30. The distance from here to here will be 42 centimeter, or we can also just convert lah, 0.42 meter. Okay, now soalan minta what is the distance from what is the distance of a point from Q1 where the electric field intensity is 0. Okay, let's say lah ada satu point dekat sini. Let's label this point as point A. So we want to find what is the distance daripada Q1 ke point A when the electric field at point A is equal to 0. So this one sebenarnya sama macam example 4. Tapi example 4 tu adalah in terms of force. Now we want to find in terms of electric field. Okay, so now since dekat sini the net electric field adalah sama dengan kosong, dan kita tahu the net electric field is equal to E1A. So sebab kita sudah gunakan label A di sini kan, E1A plus E2A, which is equal to 0. Okay, so since direction dia adalah towards the negative, so satu positif, satu negatif lah. So dekat sini apa yang akan negatif? E1A. Okay, direction macam ni kan, sama juga macam soalan A tadi. The direction will be towards the negative charge. So this will be to the left, this will be to the right. So that's why Miss letak dekat sini dia adalah negative. So now E1A will be equal to E2A. Okay, after that you just masukkan the formula KQ1 divided by R1A square equal to KQ2 divided by R2A square. Okay, before that, so basically what we want is the value from here to point A here. So kita letaklah value for X. What is the value for X here? And then maksudnya daripada sini ke sini, it will be 0.42 minus x. So this one you can cancel because it's the same value. Lepas tu masukkan Q1 is 3 microcoulomb divided by R1A daripada point A ke daripada charge 1 ke point A, which is value for x. And then Q2 is 5 microcoulomb divided by the distance from A to Q2, which is 0.42 minus x. And don't forget the square. Okay, and then after that, you just selesaikan the mathematics here. Okay, now untuk selesaikan, the easiest way is we get rid of the square here by square root both sides. So, apabila kita square root both sides, kamu akan dapat x 5x per negative 6 0.42 minus x. Lepas tu kamu akan dapat square root of 5 over 3x. Okay, please double check this one. 0.42 minus x. X will be equal to 0.1 at 3 meter. Okay, so since dekat sini we have already converted to meter, so your final answer is in meter.